Alright class, this is the video on literal equations. Basically a literal equation is taking equations that you already know but solving them again for a different variable. And that helps us later on, and I'll show you in a few problems why it's sometimes necessary or important to do that. Let's do a very basic one. It says solve for y in terms of x, which means that I need an equation that has a y equals. So I need to solve for this guy. In order to solve for it, you need to move everything else away, starting with the things that are furthest away that are attached by plus or minus. So the first thing I'm going to do is get rid of this 8x by subtracting 8x from both sides. So now I'm left with 6y is equal to 12 minus 8x. Again, you can't really combine anything, they all have letters, except for the 12, doesn't matter. Finally, I'm going to divide everything by 6. So I get that y equals 2 minus, and then I'm going to simplify 8 divided by 6 into 4/3 times x. And that is the final answer. So it's basic manipulation of the equation into another one for what I asked for. So I solve for y in terms of x. Y equals, and there's only an x variable on the other side. Alright, let's go on to some other ones then. Solve for the given variable. I want you to solve for diagonal 2. Now the first thing you should note about this equation is, and hopefully you guys remember, I believe this is the area of a rhombus and a kite. It's been a while since I did geometry. Yeah, I think rhombus and a kite. You need to notice how everything's being multiplied together. So you kind of just have to do the opposite. There's no adding or subtracting. Alright, so I'm going to do them in steps just for this video. The first thing I can do is get rid of the 1/2 by multiplying both sides by 2. So I get 2 times a is equal to d1 times d2. And then to get d2 by itself, I'm going to divide everything by d1. So my final answer is d2 is equal to 2a over diagonal 1. Okay, and in this equation, okay, what is in terms of what? Well, hopefully you guys see that d2 is in terms of the area of the shape and the other diagonal. Okay. Now it gets a little trickier when we have pluses, but remember this piece is like a chunk being multiplied by these two here. So to get to b1 we have to deal with this outside stuff first. So the first thing I'm going to do, again to get rid of the 1/2, is multiply everything by 2. So I get 2a is equal to, these 2 and 1/2s cancel, and I'm left with an h times b1 plus b2. The next thing I'm going to do is divide by h, because that's, some of you guys are like, well, can I distribute the h in? You could, but then you are going to end up having to divide by h anyway, and it's easier just to get rid of it now, because it's on the outside and it's being multiplied to that. So to get rid of it, you just divide. So we're left with b1 plus b2 is equal to 2a over h. Alright, and then finally to get to b1 you just move over the b2 by subtraction because it's attached by addition. So my final answer is b1 is equal to the quantity of 2a over h and then minus b2. And in this case, b1, or base 1, and hopefully you guys recognize this formula, this is the area of a trapezoid, is in terms of 3 variables. You need to know the area. In order to find the base 1, you need to know the height, and you need to know the other base 2. Okay? Alright, let's do a couple more. Area in terms of area equals 1/2 PL plus B. P is what we're solving for. So again, since we're solving for P, you do not want to get rid of the other stuff attached if there's a plus or minus. You need to get rid of that thing first. So we get A minus B, and then equals 1/2 PL. And again, if you get good at this, you can do this next part in 1 step. I'm still going to do it in 2 steps just for you guys. Get rid of the 1/2. So I get, you can either distribute it or leave it as 2a minus b equals PL, because this goes away when you multiply, and then finally divide by L. So you get that the perimeter of the base, I believe this is the area of a cone, or a surface area of a cone or a pyramid. Perimeter is equal to 2 parentheses a minus b all over slant height L. Okay, so the perimeter of the base is in terms of three things: the area, that's the surface area, the area of the base, B, and the slant height. Okay, and then this one's pretty basic. We just need to solve for M. This is the energy equation. You're going to learn more about that in science. So we can divide by C squared. Okay? E over C squared is equal to M. Now that we have the equation, we can write down here. Now we have to be careful though. I put an extra line here, but really, in this equation, if you knew what this equation, excuse me, what this equation is, it's Einstein's equation, energy equals mass times speed of light squared. So, the speed of light though in a vacuum is constant. So technically, this is a constant. It's a number, kind of like pi. You'll see it later with pi. So when you say it's in terms of that and that, technically it's really only in terms of the energy because of the constant. I'm not going to give you anything like that on a quiz. I would let you know what's a constant and what's not. Although you guys should know that pi is a constant. But you shouldn't know this one. I'm just explaining that it technically is a constant. So, alright, width of a rectangle is 15 centimeters longer than the length. For these kind of literal word problems, I like to just write down what they state as it goes. So I know that W is equal to 15 plus L. Write an equation expressing the perimeter in terms of the length. So now I need an equation for a perimeter. If I have, and I say that this is W and this is L, how do we find the perimeter of a rectangle? Well, it's L, L, W, and W. So it's 2L plus 2W. Okay. So it says write an equation expressing the perimeter in terms of length. Well, right now we have perimeter in terms of length and width. So we need to get rid of this somehow. Luckily, we have another equation where we have W equal to some other stuff. So we can use substitution and say, well, W is actually equal to this chunk here. So I can rewrite this as P is equal to 2L plus 2 times 15 plus L. Sometimes people get mixed up on which way to go. Like some people would try to solve for L and plug it in there. But then when you do that, you get rid of the L and you're left with W. So look for what you want to be left with. This equation will leave me with length. So then I have P is equal to 2L plus 30 plus 2L, which is P is equal to 4L plus 30. So this would be the perimeter equation for a rectangle. Then it says if the perimeter is 230 centimeters, find the dimensions. So now I'm going to take my equation, and for P, I'm going to say I have 230 centimeters, and then just write my equation. So I have 200 is equal to 4 times the length, which means that the length is equal to 50 centimeters. And now we go back to this equation for width. Width is equal to 15 plus the length. So the width of this rectangle is equal to 65 centimeters. Okay, so let's go on to some more. These have drawings with them. The area of a circular ring can be found using this equation. A equals 2 pi PW. Alright, where W is the radius of the outer part of the ring, P is the radius of to the center of the in between the ring. If the ring is the this big P, all the green, I should say. Alright, solve for P. So the first thing we're doing is just solving this equation for P. Well, you guys can do this all in one shot because there are everything's being multiplied together. So in order to get everything away from P, I just have to divide everything I don't want. So I have an equation where P is equal to A over 2 pi W. Now again, if I ask you what is this equation in terms of, this is P in terms of A and W only, because pi is a constant. Now that we have this, we can solve for the radius to the center of the ring,
when I give you some other values for A and W. So now we're just plugging in values. So the radius to the center is equal to 22 over 2 pi times 2, which is equal to 22 over 4 pi. And if you can simplify, try to. 22 divided by 4 is a fraction of 11 over 2. And this is in centimeters. Okay. Next, we're going to do the same thing, but with a track. Here's an equation. X is the length of the rectangular part of the track. R is the radius of the circular parts of the track. This equation should make sense. To do a perimeter around the track, we have two x's. That's where this 2x comes from. And then we have half a circumference and half a circumference, which is a full circumference. And you should remember that the perimeter of a circle or circumference of a circle is 2 pi r. So this equation should make sense as it is right now. Now, solve for r. So again, when you're solving and there's pluses and minuses, first thing you should do is get rid of the thing attached with plus or minus. So subtract 2x, so p minus 2x is equal to 2 pi r. Now we solve for r by dividing by 2 pi. Divide everything. You can leave it like that if you want. So we get r is equal to p minus 2x all over 2 pi. Okay? So this equation will give you the radius of the circular part of the track. If you know the total perimeter, if you know the length of the rectangular portion. And again, pi is constant. So it says solve for r and then find r when p is 440 and x is 110. So r is equal to 440 minus 2 times 110 all over 2 pi. 440 minus 220 is 220. And so we get 220 over 2 pi. And that gives us 110 over pi. And the units for this for a radius would be yards. Okay, last two problems. These are kind of fun, and actually these are kind of important problems you'll see. It's using graphs and substitution to solve for equations to get them down to one variable. So we have an isosceles triangle that has a vertex at the origin. So here's 0, 0. We know that. And two vertices on the graph of y equals 3x squared. So that's what this graph is. Y is representative of that. So what we're going to do is find the area of this triangle as a function of x right now. So the first thing you need to know is what is the area of any triangle. Well, the area of a triangle is 1/2 base times height. So now we have to convert base and height to our diagram. The height starts at 0 and then moves up in the y direction, and then it goes up to y. Do you see how this point is x comma y? So it goes up to y. So that's what our height is equal to. Our base are these pieces added together. Well, remember, this is 0, 0 down here. This is 0y up here. So to go from 0 to x, we moved a distance of x. To go from 0 to negative x, we moved a distance. Again, don't worry about the negative sign because we're talking about a length now. You've moved x units. So the total base is equal to 2x's if you add those together. Okay? So now we have the area. We're going to sub in equals 1/2. The base is 2x, and the height is just y. We're almost there. It says express the area as a function of x only. That means we cannot have y. If only we had an equation that had y in terms of x somewhere. And sure enough, I actually gave you that in the problem. Y is actually equal to 3x squared based on this graph. So, area equals 1/2. We still have the 2x for the base, and then y becomes 3x squared. So we can simplify this by those cancel. X, you get area is equal to 3x cubed, and then whatever the units are, so square units. Alright. Next, we have an isosceles trapezoid. Same thing. Same exact problem. The only difference is we have a different area formula. I talked about this in the front of the page. Area is 1/2 times the height times the bases added together. So we have to find all these pieces. So again, the height goes from 0, 0 up to, and when I deal with the up direction, that's y, so it goes up to y. So that's the height. The bases, From here to here is 2x long. From here to here is 2x long. From 0 to x is x. From here to here it's x. So that means that base 1 is 2x, base 2 is 4x, and this is equal to the height. Now I can plug all those values in. The height becomes y. This becomes base 1, which is 2x, plus base 2, which is 4x. The last thing is we have to sub in for y. Sure enough, there is an equation in terms of x, so we're going to plug that in for my y value. And again, we're doing this so we get it down to one variable. And then this becomes 6x. 6x times a half is 3x, so I'll get rid of that real fast. And then finally, you can multiply that in, and we get an area equation of 12x minus 3x cubed. And that's going to be in units squared again. Okay, so those are literal equations. Again, the important thing is getting the equation first, area of these shapes or whatever I give you, solving for the variable, and then for these later ones, using another equation to sub in to get rid of a variable. So for, again, these two problems, we did not want y, so we used the equation for y. We did not want y up here, so instead we subbed in for y equals 3x squared. Alright, and that is it for literal equations.